Good morning, dear students. Welcome back again with a new session of Maths 1, lesson number 3, arithmetic progression, exercise 3.2. In question number 1, 4 activity based sums are there, which is very easy, which you can solve it of your own. So, we'll move to question number 2. Decide whether the following sequence in AP, if so found, find the 20th term of the progression minus 12, minus 5, 2, 9, 16, 23, 30, and so on. T1, that is first term, equals to minus 12, second term is minus 5, third term 2, fourth term 9, fifth term 16, sixth term 23, seventh term 30, and so on. Now, as per the rule, we want to find out the common difference. If the difference is same, we can say that the given sequence is AP. So we'll check it out whether the difference is same or not. So for that, T2 minus T1, it is found to be 7. How? 5 minus 7. Sorry, minus 5 minus 7, that is minus 5 plus 7. So minus 5 plus 12, that becomes 7. Similarly, T3 minus T2 is 2 minus 5, that is 2 plus 5, that is 7. T4 minus T3 is 9 minus 2 equal to 7, and so on. We can see that at difference between the two consecutive terms of the sequence is same, that is D, and therefore we can say that the given sequence is an arithmetic progression. Now, if the given sequence is arithmetic progression, we have to find out the 20th term. For that, we have to use the formula Tn. First of all, we'll write the formula. The formula for Tn is A equals to n minus 1 into D. Now, T20 we have to find out, that is 20th term. So imply that n is 20. First term, we already know it is minus 12. Since n is 20, so here 20 minus 1 into D. Common difference is constant, that is 7, which you already got it. And therefore D equals to 7 here. Now after opening the bracket, minus 12 plus 20 minus 1 is 19, 19 into 7. Minus 12 plus 19 into 7 is minus 12 plus 133, that becomes 121. Therefore, the 20th term of this sequence is 121. Now, next question. The given sequence is 12, 16, 20, 24, and so on is an AP. Already given it is an AP. We have to find out the 24th term. So we have to find out which is the 24th term. That is C24. So n is given here already. A we know first term, that is with the help of the sequence we can get the first term, that is 12. And since it is given that it is AP, therefore only one difference is sufficient to prove. 16 minus 12 is 4, so the common difference is 4. So we got all the terms. A equals to 12, D equals to 4, N equals to 24, T24 we have to find out. Apply the formula of Tn. Tn equals to A plus N minus 1 into D. A is 12 as already written, and we have to find N is already given 24 minus 1 into D. D is, we have found it out, T2 minus T1, that becomes here 4. Put the values in the formula, and then after putting the values we get here 12 plus 23 into 4, 23 4s are 92. So 12 plus 92 becomes 104, and therefore the 24th term of the sequence is 104. Now question number 4 and 5 are same, so I expect that you can do it of your own. So we'll move to now question number 6. Find how many three-digit natural numbers are there between divisible by 5. So here 3-digit natural number divisible by 5 we have to find out. For that we should know the smallest 3-digit number divisible by 5 and the biggest or largest 3-digit number which is divisible by 5. So smallest 3-digit number divisible by 5 is Nothing but 100. 100 is divided by 5, we get 20. So here definitely 100 is the smallest 3-digit number divisible by 5. The biggest 3-digit number is 995. The 3-digit number is biggest is 999, which is not possible divisible by 5, and therefore go on reducing up to 995. And therefore the smallest 3-digit number divisible by 5 is 100, and the largest or the biggest 3-digit number divisible by 5 is 995. And since it is divisible by 5, therefore common difference will be 5. Therefore D equals to 5. So first term we got, last term we got, and the common difference also we have got it. Now very simple, we have to find out how many terms are there, that is n we have to find out. Okay, so we have to apply the same formula, the only formula which we have learned before this exercise, that is Tn equals to a plus n minus 1 into d. Tn equals to a plus n minus 1 into d. Put the values here. Tn 995, a 100, and we have to find out minus 1 into d, since it is multiple of 5, so therefore d is equals to 5. Now open the bracket, 5 into n, 5n minus 1 into 5 is minus 5, so 100 minus 5 is 95. 995 minus 95 equals to 5n. Therefore 900 equals to 5n, and therefore n is equals to 900 upon 5, which is nothing but 180, which implies that the 3-digit number divisible by 5, total 180 terms are there. With the help of this formula we have found out. Now we will move to the next question. The 11th term and the 21st term of an AP are 16 and 29 respectively. Find the 41st term of that AP. So here already given here 11th term is 16, therefore T11 equals to 16, which implies that n is equals to 11. Equation 1. 21st term is 29, which implies that n equals to 21, that is second equation. Now since we have used the formula here Tn, therefore apply the formula of Tn. Tn equals to a plus n minus 1 into d. So for the first equation when we will apply it, T11 equals to a plus 11 minus 1 into d. Now T11 value already we know in the equation 1 we have got T11 value is 16. So 16 equals to a plus 11 minus 1 is 10d. So we got here 3 equations, first, second, third. Now we have to find out the fourth equation. 21st term, which you have already known, it is given as 29. So here again use the formula Tn equals to a plus n minus 1 into d. T21st equals to a plus 21 minus 1 into d from equation 2. Now put the values here. T21 already we are knowing it is 29 equals to a plus 21 minus 1, that is 20d. Now with the help of equation 3 and 4 we have to solve it simultaneously, and we have to find out the value of a and d. With the help of a and d we can find out the 41st term. So how to find out? Now looking at the equation 3 and 4, we know that one constant term is there with same coefficient, that is a. Unknown term a is there, coefficient is same. Very simple, just subtract equation 3 and 4, we'll get the value of d. And therefore here fourth equation and third equation is written here, subtracted, and we get here 29 minus 16 is 13, a minus a is 0, 20d minus 10d equals to 10d. Therefore 13 equals to 10d and d equals to 13 upon 10. Now putting this value in either equation 3 or 4, we can get the value of a. So I have decided to put this value in equation 3. After putting the value of d equals to 13 upon 10 in equation 3, we get the value of a. Let's see how. 16 equals to a plus 10 d is equation 3. 16 equals to a plus 10 into value of d. Just now we got 13 upon 10. 10 gets cancelled. Therefore 16 equals to a plus 13. Therefore a equals to 16 minus 13. A equals to 3. So we got d, we got a. Since we have to find out 41st term, and also we have got, so we have to use the formula Tn equals to a plus n minus 1 into d. T41 equals to 3 plus 41 minus 1 into d, that is 13 upon 10. Putting the values here, 0 0 we can cancel it. 3 plus 4 into 13, 13 4s are 52, so 3 plus 52 is 55, and therefore T 41st term equals to 55. Thus we have solved this term also, this sum also. Further, moving to the next sum, the given sequence is 11 8 5 2. In this AP, which term is the number minus 151? So A equals to 11, D as it is given that it is AP, therefore only one difference is sufficient, therefore D equals to minus 3, and Tn is already given. The term whose number we have to find out, term is 151, and number we have to find out which number it is, that is n we have to find out. So applying the formula Tn equals to a plus n minus 1 into d, put the value Tn is 1 minus 151, a is given as 11, and we have to find out minus 1 into difference is already we are knowing it, minus 3. After opening the bracket, we get minus 151 equals to 11 minus 3n plus 3. 11 plus 3 is 14. So minus 151 equals to 14 minus 3n. Therefore 3n equals to 14 plus 151, that is 165. Therefore n equals to 165 upon 5. That becomes, minus 165 upon 3. Therefore n equals to 55. Therefore the term 55th term is nothing but minus 151. Now few more sums are there. With a natural number from 10 to 250, how many are divisible by 4? So between these two numbers, we have to find out how many numbers are divisible by 4. The smallest number between 10 to 250 divisible by 4, and the biggest number we have to find out. So smallest number divisible by 4 between 10 to 250 is 12, and the biggest number divisible by 4 between 10 to 250 is 248. So smallest and the biggest number, we have got it. And since it is divisible by 4, therefore D is also equals to 4. First term 12, common difference 4, last term 248. Now apply the formula Tn equals to a plus n minus 1 into d. Put the values. 248 equals to 12 plus n minus 1 into 4. 248 equals to 12 plus 4n minus 4. After opening the bracket, 4 into n, 4n, 4 into minus 1 is minus 4. So here 248 equals to 8 plus 4n. 248 minus 8 equals to 4n. 240 equals to 4n. Therefore n equals to 240 upon 4, and therefore the n is 60. Therefore there are 60 natural numbers between 2 to 250 which are divisible by 4. The last sum of this exercise. In an AP, 17th term is 7 more than its 10th term. Find the common difference. Very simple it is. So as per the formula, we know Tn equals to a plus n minus 1 into d. What is the condition given here? In an AP, 17th term. 17th term means T17. E is here is there, so you have to use here equal. 7 more means plus 7. then its 10th term, that is T10. Now it is very simple to solve. Just apply the formula of Tn equals to a plus n minus 1 into d. Applying it, what do we get? A plus 17 minus 1 into d equals to 7 plus a plus 10 minus 1 into d. Here common term on either side is a, so a gets cancelled. So what is left out? The left out term is 16d equals to 7 plus 9d. Bring the like terms together. 16d minus 9d equal to 7. Therefore 7d equals to 7. Therefore d equals to 7 upon 7, and at last d is equals to 1. Therefore common difference of this sequence, which we are not knowing it, only they have given certain conditions. With the help of that, we have found out that the common difference is 1, that is d equals to 1. Here we have completed this exercise. Remaining part we'll do it in the next video. Till then, have a great day.